Hi, everyone. Thanks for having me in your classroom. My name is Viviana, and I'm an environmental engineer. An engineer is someone who uses science and math to solve problems or to build things. An environmental engineer like me uses math and science to help clean up the environment. So the soil, the water, or the air. In my job, we figure out how to remove pollution or chemicals that are bad for us from the water and soil. And sometimes part of my job is figuring out how much pollution there is in a certain area or where it is. And to be able to figure that out, we need to understand how chemicals disperse or move around in the environment. So today, I'd like to talk to you about dispersion of chemicals in water. So to show you what dispersion in water looks like, here I have a mason jar with water in it, just plain water. Okay, and I'm going to use this food dye to be the chemical that we're interested in. Okay, so let's look at what dispersion really looks like. All right, so you see the blue going into the water. You see that I'm not really moving the jar, I'm not trying to. And the blue food coloring is just mixing, spreading out throughout the water, correct? You notice that there's areas where the food coloring is lighter and there's areas where the food color is darker. So what does that mean? So the darker areas, it means that the food coloring is more concentrated. The lighter areas means that it's not as concentrated. It's mixed a bit more with the water. So this is what dispersion really is. It's just how something spreads, in this case, in water. So what are some things that could affect how quickly a chemical is dispersing in water? I can think of a few things. How about water temperature? You think that'll have an effect? Let's give it a try. So here I have two jars. This is cold water and this is hot water. Let's see what happens when we put the dye in each of them. All right, so I put the dye in the cold water and the hot water. And what do you see happening? What do you think is happening? Hot water, see how the dye, the food coloring is spreading out a lot faster here in the cold water. Dye is just kind of staying in the middle, not moving as fast. Why do you think that is? Well, water molecules tend to move faster when they're hot. Think of boiling water. You know how the water is moving around a lot, creating lots of steam? That's what's happening with the water molecules, is they're moving around really, really quickly. So the food coloring in this one is mixing a lot faster than the food coloring in the cold water. In the cold water, the water molecules are slower. Think of ice. Ice is frozen water, correct? So there the water molecules are frozen, they can't move. So in colder water, they just move slower, so the mixing doesn't happen quite as quickly. Something else that could affect how quickly a chemical disperses in water is movement of water. So think about an ocean or a river versus a lake. An ocean water is very turbulent. You've got a lot of mixing going on, right? You've got the waves and just a lot of movement of water. In a lake, it's not as much movement. Water is a little bit more still. So where do you think a chemical would disperse faster? In an ocean or a lake? Most likely in the ocean. So let's do a simulation of that. So I'm going to stir this water. I'm going to drop in some food coloring and see what happens. See how it's mixing pretty quickly with the water? A lot faster than the other ones we did, huh? You see that it's darker up here, meaning it's more concentrated, and as it spreads out, it's still lighter down here, but it's getting darker, right? That's the chemical spreading out. So how does dispersion in water relate to what I do in my job? Well, one of the things we do is to look at chemicals in the groundwater. So what is groundwater? I'm going to share a diagram with you from the United States Geological Survey that shows what groundwater is. So this figure is from the United States Geological Survey. And it's showing you right here what groundwater is. Okay, so here we have some land, and maybe this is a lake or a river right next to the land. And under the ground, you see this, what's called the water table. And beneath the water table is the saturated zone, meaning that all this area here has water in it. Now, this isn't just plain water. This is water kind of in between gravel and sand and dirt and rocks. And above that water table is called the unsaturated zone, meaning that there's not much water in here. So what happens if you spill a chemical on the ground? Well, that really depends on whether you're close to the saturated zone or not. So here I have a simulation of ground. Okay, so we have these two jars or two bases filled with coarse sand. Okay, it's both dry right now. It's just dry sand. This one as well, it's just dry sand. Okay. Now, what happens when we spill a chemical into here? Okay, this is the dry sand. Make sure you can see that. This is the dry sand. You see that the chemical that I spilled is red food coloring. It's spreading a little bit, but not too much, right? All right, let's see what happens if we were to have a water table in our ground. So here's our ground, and we're going to add water, simulate groundwater. You see the water coming up. It's filling up all those little spaces in between the sand, right? Let's see now what happens when we add the chemical to groundwater. See how the chemical is spreading? It's getting into all those little spaces between the sand molecules, right? This is why dispersion in water is important, because you see that it spreads much faster when there's water involved. Let's take a look at the dry one and see how it compares. See how it's barely moved? And look at the wet one. It's going pretty deep down, right? So the chemical in the water, the groundwater, can spread much faster than in just dry soil. Part of my job is to see whether or not groundwater is contaminated in a certain area. Say, for example, a spill occurred. Maybe a gasoline tank burst open and a bunch of gasoline spilled into the ground and into the groundwater. So how do we see how far that gasoline got? Well, we can install wells. So it's basically a big tube that goes into the ground that reaches all the way down into the water. And then we can take samples from that well of the water to see whether or not there's any of that contamination, any of that chemical that was spilled. And we can put wells at different distances from the spill to see just how far it got. So how do we do that? Well, let's take a look. This is my coworker, Alan, and this is the top of a well. So this well goes deep down into the ground and reaches where the water is underground, the groundwater. So once we get that well open, we can stick a tube down into the well, and that tube is connected to a pump, and it pumps out the water from that well. Here's Alan. This is the pump, and that's connected to the tube that's inside the well. So the water is being pumped out, and then you can collect the samples in these little bottles. And then these bottles we can send to a laboratory where they can analyze the water for the different chemicals that we're interested in. And we can take samples from several wells at different distances from wherever the contamination was, or where the spill was, to see just how far it's gotten. So why do we want to know if there's contamination in the groundwater, if there are chemicals in the groundwater, and how far it's gotten. Can you think of any reasons? Well, one reason is that many people around the world rely on groundwater as their main source of drinking water and their main source of irrigation or water for their crops. So we don't want any bad chemicals in the water that we drink or the water that we use to water our gardens, right? Also, if you remember the schematic that I showed you, groundwater is also linked to surface water, things like lakes and rivers, right? So if there's any contamination, if there's any chemical in the groundwater, that can also get into the surface water where there's a lot of fish and other animals as well as plants, right? And then think about these trees, right? And other animals that live on land. If the groundwater is contaminated, then the roots of all these trees and other plants can also be affected by that chemical. So any animals and plants on land can also be affected by chemicals in the groundwater. So if we know where the contamination of the chemical is and how much of it there is, then we can take steps to clean up the groundwater and the soil that might have been affected by that chemical. And then we can make the environment clean and safe for people and for plants and animals. I want to thank you all very much for letting me be in your classroom today, and I hope you enjoyed this presentation. Bye.